In this exercise, we're going to be looking at finding the angle in a right angle triangle. So we use a different function on our calculator. We use inverse sine, inverse cos, or inverse tan. And this will always find the angle for us. But our working out is not overly different for the first couple of steps. We will start off exactly the same way by labelling our triangle. So let's have a look at this. Find theta in the following right angle triangles, correct 2 decimal places. So I am going to label my triangle like I usually do, and I have got the hypotenuse, and because this is my given angle, this must be my opposite side. So let's write down the information that I have. Theta is now what I am looking for. Opposite is 1. Hypotenuse is equal to 2. So what's the ratio that links those three things? Soc, cut, toa. Must be sine, mustn't it? So sine theta equals opposite over hypotenuse. And let's fill it in. So this time we don't know the angle. So it's still sine theta, 1 over 2, because the opposite's 1, the hypotenuse is 2. Now I want to get that theta by itself. To get the theta by itself, I've got to bring the sine over the other side. And when I bring it over the other side, that's when it becomes inverse sine. And it's inverse sine of a half. We put that into our calculator. You'll find inverse sine in exactly the same spot as sine on your calculator. So when I put that in, I get sine, inverse sine of a half, theta becomes 30 degrees. Let's keep going with this example. Let's start off exactly the same way. So here's my given angle. So what do I have here? I have my hypotenuse and I have my adjacent. Writing out the information. So theta is equal to, well, we don't know, that's what we're looking for. Adjacent is 1.5 and the hypotenuse is equal to 2.5. Okay, soc, cut, toa. Of course, cos theta, we know this now. So cos theta is adjacent over hypotenuse. Let's fill it in. Cos of theta, again it's our unknown, 1.5 over 2.5. I want to get the theta by itself. Bringing the cos over the other side becomes inverse. So it's 1.5. Notice how I've got that inside a bracket? Because it's inverse cos of the whole thing. And when we put that into our calculator, we get 53.13 degrees. It wanted the answer to 2 decimal places, so that is a decimal degrees, 53.13 degrees. One more. So labelling this triangle, here's my given angle. Alright, so that must be my opposite, and this must be my adjacent. Theta is what I'm looking for. Opposite is equal to 15. Adjacent is equal to 8.2. Soc, cut, toa must be tan. Tan theta equals opposite over adjacent. Tan theta, filling it all in now, is equal to 15 over 8.2. And of course, theta is equal to the inverse tan, bringing it over the other side, of 15 divided by 8.2. And when I put that into my calculator, I get 61.34 to 2 decimal places. And remember, that is degrees, 61.34 degrees. So when we are looking for an angle, we use inverse sine, inverse cos, and inverse tan.